Hi everyone, in today's lesson we're going to learn how to write polynomial equations given the roots. So the first thing I'd like to do is quickly factor these two expressions. So if you factor the first expression, you should get x minus 3, x minus 2. And if I want to solve, I'll set each piece equal to 0, and my roots will be 3 and 2. And again, if I quickly factor this one, I'll get x minus 4, x plus 3. And if I want to find the roots, I'll set each piece equal to 0 and get x equals 4 and x equals negative 3. Now I want to show you something unique about the sum of the roots and the product of the roots and the equation that you can build from that. So if I were given just the sum of the roots, or if I were given just the roots, I could add them and find their sum. I could also multiply them and find their product. So if you notice, when I look here, the sum of the roots 5 is opposite the middle term. The product of the roots 6 is equal to the last term. Let's see if that's the same rule for the second. So if we find the sum of the roots, 4 and negative 3, we get 1. And when we take the product, we get 4 times negative 3, which is negative 12. So it looks like the product is the same as the last, but the sum of the roots gives us the negation of the middle term. So this will come in handy when I have roots and I want to find the equation. So what you're going to do is take x squared, negate the sum, and add the product. Alright, and that will always give us a quadratic equation if I have two roots. Alright, so now what I would like to do is look at the factored form of certain polynomials, and I just want to draw some conclusions. If x and x minus 1 and x plus 2 are the factors, then my roots are 0, 1, and negative 2. So that's relatively easy. So if I give you a root of, say, x equals 3, then the factor must have come from x minus 3. So it's the opposite sign. So this would be my factor. Okay, now let's take a look at the second example. I have a little bit more terms here. Okay, so the first one, x is 0 and x is negative 6 are my roots. Now the second two here are a little bit harder, but you would just do 3x minus 1 equals 0, add the 1, and divide the 3. So x equals 1/3 would be a root, and if I follow that same pattern, then x equals negative 3/2 here. So the hard part is saying how to create the roots, the factors given the root. So say if I have a root of x equals 1/2, how would I find its factor? So the way that I want to do this is work backwards. So if x is equal to 1/2, that could come from x minus 1/2 equals 0. And we can't put that inside the parenthesis for a factor. So what you want to do with this trick that I'm going to teach you is multiply this parenthesis by 2 so that I can multiply everything and it will cancel out this 2 on the bottom. So when I do that, I get 2x minus 1, and 2 times 0 is 0. So this is what my factor would be. Okay? So how does that work? Now I want to build a quadratic equation given two roots. So the first thing that I could do was recognize that if negative 4 is a root, then that must have come from x plus 4 as a factor. And if x equals 1/2 is my root, I know that that comes from 2x minus 1. So if these two things are my factors, all I would have to do is double distribute and I could get my final answer. So take a minute, pause the video, and double distribute, and then hit resume for the answer. Okay, you should have gotten 2x squared minus x plus 8x minus 4 with like terms here, which add to 7x, and I have a 2x squared in front. So this would be my f of x function, or my polynomial function, given these two roots. Now, I could also do it another way. Given that I have these two roots, I could use the sum and product trick. I can say, well, I can take their sum, so negative 4 plus a half, and then I could take their product, negative 4 times a half. So the sum will add to negative 7 halves, positive 7 halves, and the product will multiply to negative 2. So if I'm putting this into the formula is x squared minus the sum x plus the product. So I'm basically going to negate the sum. Okay, so negative and then 7 halves is the sum, x, plus the product, or plus a negative 2 is the same thing as just saying negative 2. But now what we're going to notice is that this quadratic has a fraction for a coefficient, and we're not allowed to have fractions. So we can kind of use that same trick that we used before to get rid of the half, is we can actually multiply this entire equation by 2. And by doing so, we will get 2x squared minus 7x minus 4. When I multiply the 2 and the 7 halves, the 2 and the 2 will cancel. So this is my polynomial equation that will have f of x in front, and this is the same as this. So these are two different methods to do the same thing. Alright, let's move on to the back. Alright, so what I want to do is recall factoring and solving polynomials. So in this first particular example, there's a GCF of x. And I'm left with x squared minus x minus 12. And I can factor x minus 4, x plus 3. And if I'm asking to find the roots, I can get 0, 4, and negative 3. Okay, now how about something a little bit different? With the second example, I will never find factors of 1 that will add to negative 5. So the only way to solve this is through the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals 5 plus or minus square root of 21 over 2. So you should be noticing something particularly important here, that when you use the quadratic formula, you're either going to get a whole number or a fraction, so something that works nice, or you're going to get this radical or an I if it's negative. So irrational roots, which are radicals, and complex roots come in what we call conjugate pairs. Meaning this root would be 5 halves plus rad 21 over 2, or 5 halves minus rad 21 over 2. So you can't have one without the other. So if I'm asking you to build a polynomial equation, given these two roots, you have to know that there exists the conjugate pair. So there exists negative 1 minus 3i, and on this one, it exists 5 plus radical 10. So you have to know that without it being written. So technically I have 1, 2, 3 roots, so I should have a polynomial equation that starts with an x to the third. So we can use the sum and product trick from before, but we're going to have to combine it with something we learned on the first page. So I'm going to look at these two, and I'm going to find their sum. Okay, and I notice that the 3i and the negative 3i cancel, so my sum is negative 2. Then I'm going to find their product. Okay, negative 1 plus 3i and negative 1 minus 3i. And we're going to begin our double distributing. Negative 1 times negative 1, negative 1 times negative 3i, 3i times negative 1, and 3i times negative 3i. These cancel, and I squared becomes negative 1. So this is really 1 minus negative 9, which really is 10. Okay, so if I put this together, I'm going to write it as x squared plus 2x plus 10. I chose plus 2x because I'm negating the sum and keeping the product. So this is the quadratic equation that would have these two roots. So just the one last thing I need to do is take down this 0. If 0 is a root, where did it come from as a factor? Nothing other than x. So we're going to just distribute this in, and we'll get x to the third plus 2x squared plus 10x. And that is my polynomial equation. Okay, let's try a little bit harder of a problem. So we're going to do the same thing. We're going to take the two conjugate pairs and find their sum. So 5 minus rad 10 plus 5 plus rad 10. The rad 10s will cancel, and I'll be left with 10. And their product, 5 minus radical 10 and 5 plus radical 10. Again, we'll double distribute. So 5 times 5 is 25. 5 times radical 10. Negative radical 10 times 5. And negative radical 100. These are going to cancel. So I really have 25 minus 10, which is 15. I got 10 because the square root of 100 was 10. So if we put it all together, in the equation, it's always x squared minus the sum plus the product. So minus the sum x. If the sum was positive 10, I negated it in the formula. So this is the quadratic equation that will have these two as roots. So the last thing I need to do is bring this root down in factored form and put it outside here and then distribute it in. So let's talk about how I could do that. If x equals negative 3/4 is the root, it must have came from x plus 3/4 equals 0. But that's weird. We can't have that in a parenthesis when we're trying to build backwards to factor. So what we're going to do instead is multiply both sides of this mini equation by 4. The reason why I chose 4 was because it was the denominator to this fraction. Because I know if I multiply 4 times x, I'll get 4x, and 4 times 3/4 will give me 3. So 4x plus 3 goes here. So all you have to do is double distribute what's in here, and you'll get your polynomial equation. Please hit pause and then hit resume when you're ready to see the answer. Okay, here is your answer. I got positive 4x to the third minus 38x squared. Oops, excuse me, I see my mistake already. That should be negative 37x squared plus 30x plus 45. All right, jot down any questions that you might have, and then be sure to ask them tomorrow in class. All right, have a good night.